Alright, this is my video 2 for the Game Engine 2 Final Sprint submission. In this video, I'll be detailing the collision systems within the engine. So starting out with the updated collidable, we now have get B-sphere and get B-sphere reference, which allow accessors to the B-sphere collider that all collidables have by default, which will be created when the collidable is created. And then we also have just a generic collision volume type. And we have the enum here of the 3 different types of collision volumes that we can have. And then we have the actual methods. So we have a set collider, which will take in the model and then what type of collision volume user wants, and then we create a new collision volume based on that. And we have the update collision, which will just update the data for the collider, and a get collision volume just to get a reference to whatever collision volume has been created for that game object or that collidable. And then going back, went over this in the previous video, but we have all the various collision volumes, which the only data they maintain is relative to their selves. They don't have any graphics objects or anything, but they all use the visitor pattern for intersect. So we have that in the B-sphere as well as in the bounding boxes. The ABB and the OBB maintain the same amount of, or the same data set, since ABBs will be treated as OBBs in AABB, OBB collision tests. We can see here they're all using the visitor pattern. So if we actually look in the tools folder in the AtlasMathTools, we have all the new intersect functions for all the different types. So we have B-sphere with all 3 types, AABB with all 3 types, and OBB with all 3 types. And then a base that is just a collidable with a collidable. And then down here would be all the helper functions. And then we have, this is a intersect function that exists for the terrain to use, which is just a collidable type with the AABB of the cell of the terrain. That will be in the next video. Looking in here, we just have B-sphere with B-sphere, B-sphere with AABB, and then B-sphere with OBB, AABB with AABB, so that again, and then this is AABB with OBB, just treating the AABB as if it were an OBB, and then running the SAT test on all 15 axes, and then returning false if there's no overlap on one of the axes. This is just the terrain intersect, which has another level to go through to determine the type of that collision value on that collidable. And then we have, this is the OBB, which would be the same as the top one, but they're actually both OBBs, but it works the same way. And then down here, these are all the helper functions. This was a lerp, which just is a linear interpolation from A to B by the value of t, so you get basically like a percentage of from A to B. This was used for the smooth rotation, which I eventually replaced with move towards F, which you can use as move float value current towards target. a maximum amount per frame, then you would just store back what you're getting, which allows me to keep updating rotations and start rotations, which wasn't working with using the lerp. These are just conversion functions from radians, degrees, and degrees to radians. Sine is used in move towards f, which just returns 1 if the value given is positive and -1 if that value is negative. Get y angle just takes in a matrix and can return your rotation on the y-axis, which was helpful for debugging. Clamp is used in the intersect functions to clamp a value to a min and max. Magnitude just gets the magnitude of a vector. Comes in, you can give it to x, y, z, or give it as a vector itself. Projected was a projection of v onto w. These are the overlap functions used in the SAT tests, and the projection max is used, as well as two functions that, given two floats, just returns the max or the min of the two. But if we come back up to the collision, we have the collidable group, which has its own command, the ABB command, and it contains a collision volume ABBB. It maintains a collidable collection that is a list of collidables, and then every frame you're pretty much running through all the collidables and computing the data based off that B-sphere. So depending on how many B-spheres you have, you're updating the ABB to include all of them. So if we look at something like the test pair command, and the test group command, we're just calling the calculate ABB to keep computing the data, and in the test pair command, we can see the tiered collision where we're starting with the AABB with the B-sphere, and if that hits, we're going to show the B-sphere. And then we'll test B-sphere against B-sphere, and if that hits, then we'll test the actual collision volume that is on the object, which could be an AABB, OBB, or that could also be a B-sphere as well, and then we'll test that. So we can run this and see what it looks like. The enemy and allied tanks come from the same base class, which is what they're registered as for collision, so they are part of the same AABB. You see, if we come into that, then we come down to the B-sphere level, and then if our B-spheres collide, and then on the OBB level, which I can't go into them, but see that it will again for see that the OBBs then hit. Look in the images. Yeah, we have the new add AABB command, which is a new list of collision group test commands. which is then executed in the process collisions after the other commands. Yeah, and then when we're calling delete on the collision manager, we're running through the list of all our commands and calling delete, and then calling execute on these delete commands, which are specifically for deleting the collidable groups. But that is the collision system.